This is note-taking guide 4.1. It's called literal equations. Really what we're doing here is we're rearranging equations into a different order. So on this first problem up here, it asks us to solve for x. So my goal would be to get x all by itself on one side of the equation. I like to use the isolate method where I kind of just like to look at it, see where it's at, cover it up even, and just move what's not directly attached to it. So this 16 right here is not exactly attached to that x right now. It's not the closest thing to it. So I need to get rid of the 16 by moving it to the other side. Over here it cancels, which leaves me with the 4x. And over here I have 2y minus 16. Now my goal is still to isolate this x right here, and in order to get it by itself I need to get rid of the 4. The 4 is times by the x, so I'm going to divide everything on the other side by 4, as well as dividing this side by 4. The 4 divided by 4 over here cancels to just x, and then over here I'm just going to reduce on my calculator. If I put 2 over 4 on my calculator, it reduces to 1/2. I still have my y there. And if I put 16 over 4 on my calculator, it will reduce to 4. So I just solved this literal equation for the variable x by isolating the variable x on one side of the equation. Our second example is y equals negative 3x plus 10. Again, I'm solving for the x. So I like to just kind of circle or box out the part that is attached to or closest to the x variable. And that helps me see that I need to get rid of this 10. I'm going to subtract this 10 over to the other side because it was added on the side that it was on. And I can't combine these together. They're not like terms, so I'm just going to write the variable first and then the constant number. So y minus 10. And on the other side it will be equal to a negative 3x. To get x by itself now, again, just kind of look at it and see what it's attached to. I've got to get rid of the negative 3. Because there's no symbol between the 3 and the x there, we know that it's multiplication that's happening. In order to get rid of multiply by negative 3, I'm going to divide by negative 3. I have to divide everything on this opposite side here by negative 3, and I'm just going to let my calculator do the simplifying. On this side over here, I'm going to cancel those negative 3's and be left with just x. On this one, that's just one y there, so I would have a negative 1/3 y. And then I'm going to have a negative 10 divided by a negative 3, which is going to make a positive. And I'm really just going to leave that as 10/3. It's not going to simplify any better than that. Now I could actually rewrite that a little bit different if I wanted to. I could have a negative 1y plus 10, and it could all be written over 3 if you like the way that looks better, but most of the time we would leave it in this form. Alright, here's our third example right here. On the instructions of this one, I might have cut them off when we were looking at this, but on the instructions it said to solve for v. So I really want to isolate this v right here on the one side, and it already is. So I don't actually need to solve for v at all. It's already on one side. So let's pretend that these instructions are wrong, and let's say it asks us to solve for r instead. So let's say we're going to isolate the r so that we can actually do some work with this problem right here, as opposed to it already having been done for us. So let's say we're solving for r. We're going to isolate the r, which means I would have to get rid of the 4/3 and the pi. 4/3 and pi are multiplied by the r cubed, so I would divide it to the other side. When I divide by a fraction, I actually get to flip the fraction upside down and multiply by it instead. So that 4/3 right here flips upside down to be 3/4. So I would have 3/4, and I would still have v over here, and then I would still be dividing by pi, so it would be on the bottom. On the other side, I would have r cubed. I need to get rid of the cubed on the r, which means I would cube root both sides. And this turns out quite ugly, but I'm going to have r on this side from the cube and the cube root canceling. And on this side, I'm going to have the cube root of 3v over 4 pi. This last problem right here in the instructions, that asks us to solve for h, which means we're getting h by itself on one side of the equation. In order to do that, I need to get rid of all of the stuff that it's attached to. So I need to get rid of the 1/2 and the b1 plus b2. All of that stuff is multiplied together, so I'm going to divide it to the other side. So I'll have this a over here. I'm going to divide it by the 1/2, and I'm going to divide it by b1 plus b2, and then set it equal to h. The only thing that it looks like I can simplify here is to get that fraction. Instead of dividing by 1/2, I can flip that upside down and multiply by 2 over 1. So I actually end up with 2a. I don't have to show the 1 on the bottom, so I can just do b1 plus b2 on the bottom equals h.